Today's video, here is a nice promise coming from Austrian Mathematics Olympiad edition 1993. Here is the following information. For all x and y as positive integers, satisfy this following equation. So we have the difference of these consecutive integers with different exponents, x and y, equals number 7, okay? So in fact, this is a very beautiful problem. So for this video, I'm going to provide the easiest method. For the next video, I'm going to provide the challenge method, okay? So this method will be more quicker, so the other one it will be a little longer. So I'm not going to do it in next video. Next video I will have a different problem, but I'm going to do it later. Before we move on to the solution, I would like to say do not forget support the channel by like, comments, subscribe. So now let's go ahead, jump into the solution. So first of all, the easiest way to solve this equation, I'm going to prove the parity of x and y, okay? So I'm going to prove x is an even as well as y, okay? If I will be able to do that, I will have a difference of two squares. I will factor out these two terms into a product. Let's do that. So we are going to start with the parity of x by reducing this equation to the mat 3, okay? I'm going to split this number 2 into two parts. I get 3 minus 1 equals 2. So I will have minus 1 all to the x minus this one 0 because it will be divisible by 3 here. So this one is a congruent. I get here 7 equals 6 plus number 1 is a congruent to 1 mod 3. Why 1 mod 3? Because 7 equals 6 plus number 1. So we know 6 is 0. I will be left with number 1. So I'm going to remove this 0. This one is immediately telling us x is an even. Okay? So if x is an even, I'm going to put it on this form. X equals to n. So we're done with the x as a parity. We know x is an even. Let's move on ahead to check the parity of y. This time I'm going to reduce this equation to the mod 4, okay? So I will have the following. Before we're reducing the equation to the mod 4, so I'm going to consider the condition. For all x is super equal to 2, I get 2 to the x is a congruent to 0 mod 4. Because as you keep in x above this point, we will have always this term is divisible by number 4, okay? So now let's check the other one. So we get 0 because I'm reducing the equation to the mod 4. This one I will have minus 3, it will be transferred as 4 minus 1. So I get minus 1 all to the y because we know 3 equals 4 minus 1, 4 will be 0. I will be left with minus 1 to the y, which is a congruent. Also 7 equals 8 minus 1, which is a congruent to minus 1 mod 4. Okay, it's more simple. This one is 0 because you replaced it with this one here. So now I will have a reduced expression. Also, I'm going to cancel this minus sign with this one. I will be left with minus 1 or is raised to the y, which is a congruent to 1 mod 4. Okay. So I have ended with this nice statement. So this one immediately is telling us y is an even. Okay, because you're raising minus 1 to the next point, which is an even, is always, this one is turned into 1. 1 is a congruent to 1 mod 4, which is true. Okay, so we know y is an even. Let's set y equals to m. So I get these two important information. I'm going to take this both found facts at the top and continue solving this equation. Notice here, before we move on to the next step, so I have determined the parity of y, which is even, but on this condition we now have x is super equal to 2. But what about if x equals 1? We need to check that case as well. Okay, so for x equals 1, I'm going to replace number 1. I'm going to replace x with number 1. I get 2, which equals 3 to the y, which equals 7. So when it's telling us I'm going to move over this 7 to the left, I get minus 5, which equals 3 to the y, which is clearly it's impossible. Okay, so the solution will be on this one now, on this condition. Now let's keep going with this solution. Previously we worked on this equation and came up with this nice facts. We found the x and y are even integers. Now we are going to replace those values of x and y into this equation. I will have a difference of two squares. Okay, so we'll have the following. I get 2 all is raised to the 2n minus 3 is raised to the 2m, which is a difference of two squares. I'm going to factor out, so which equals number 7. So I get a difference of two squares. Now we are going to factor out that on the form of the product. I will have the following. I get 2 to the n minus 3 to the m, factor 2 to the n plus 3 2 to the m, which equals number 7. Okay, so now the solution is more clear here. One of the term is going to take number 1, the other one is going to take number 7. Okay, so which one is going to take number 1? It's clearly this one, because this one is smaller than this one. So I'm going to transfer this one into the equation system. I will have the following. Clearly I get 2 to the n minus 3 to the m, which equals number 1. The other one I get 2 to the n plus 3 to the m, which equals number 7. So it's more simple. Simply I'm going to add the first equation on the second equation. I get a error of 3 to the m because this one is negative, the other one is positive. So which means I get 2 times this one. In the other word I get 2 to the n plus number 1, which equals 8, because 1 plus 7. 8 is going to be written on the form of 2 cubed. Okay, then right away I'm going to put n plus number 1 equals 3. In the other word, n equals number 2. If n equals 2, which means x equals 4. Okay, since we found n equals 2, I'm simply going to replace it here into this equation. So with number 2 here, this one is given as 4. I get 4. So this equation is going to tell us, so I get 4. By moving over this number 1 to the left, I get 3, which equals 3 to the m. Thus m is going to take number 1. Okay, so I have determined m equals 1 as well. So which means m equals 1. I'm going to remove this m from here. So I get y equals 2. So finally I found one solution for this equation, which is x equals 4 and y equals 2. By the way, don't forget to hit the subscribe button and support the channel. Thank you for watching. I will see you next video. Bye.